Hello and welcome everyone. Happy Monday. We're really glad to have you here for the next session of our Devon and Beyond Security series. If you missed any of the previous sessions, you can find the recordings on the same Devon and Beyond page from where you registered. And while you're there, take a moment to review the other series and webinars that we have added for you. You can see those series on the screen. Our topic today is DNS architecture on OCI. In addition to covering the core concepts, we'll also talk about how Oracle's globally distributed DNS service offers enhanced performance, resiliency, and scalability to end users. My name is Renu Bhatt. I'm a program lead with the customer enablement team here at Oracle. And today we are lucky to have Radu, Marius, and Aditya, three great presenters with us as the main presenters. With that, please enjoy the session. Radu, take it forward.
Thank you, Renu. Hi, everybody. So as Renu said, welcome to a session for DNS architectures on OCI. Let's meet the presenters. I'm Radu. I have my colleagues Marius and Aditya. Together, we'll cover today's topics. Let's look a little at the agenda for today. I'll be talking about OCI Public DNS. We have some core concepts to discuss. Then we'll focus a little on advanced features like traffic steering and zone transfers. Marius will be covering private DNS solutions with, again, core concepts and the most common DNS architectures for the private side. And Aditya will do some demos related on the most implemented architectures for private DNS. And in the end, we'll do, a QA session.
Sorry to interrupt you, Radu. Can you tell me what's the difference between private DNS and public DNS?
That's a very good question. Well, I guess the main difference is, the scope of the system. While, the public DNS is intended for the whole world as an open system, anyone can interact with. When we're referring to private DNS, that's a more limited in scope, right? You have some private internal domain, only specific users can access it. Mainly, there are two different systems. Oracle implemented them in two different ways. They still work on the generic DNS architecture, but there are some very specific use cases for each of them. Okay, let's discuss OCI Public DNS. Let's dive into some details. So OCI Public DNS, well, it's secure. Why? Because Oracle automatically protects all of the DNS servers in all of the regions against volumetric DDoS attacks. So you have that out of the box without any intervention. It's reliable because public DNS zones are automatically replicated to all regions. Oracle has DNS servers in all regions, and any zone configured inside Oracle will be replicated across all these regions. It's fast because we use Anycast to serve clients. So any client doing a request will be directed to the closest OCI region, and they will get the response from there. And it's versatile because on top of everything that I previously said, we have advanced features like DNS Traffic Steering and Zone Transfers. And I'll get into all of these a little later. So when we're talking about Oracle Cloud's public DNS solution, as I said, it spans all of OCI's regions, which are more than 40 at this point. We do support OCI to be either a primary zone or a secondary zone. So you can implement advanced architectures. We have traffic management, and I have some more detailed slides on that. But we are able to control the traffic based on traffic management steering policies. We can do HTTP redirects, and the OCI Public DNS service is fully integrated with the OCI Health Check service, which will health check your public application and provide responses or details on the health of that application. We can import zones in the standard bind format. We support both IPv4 and IPv6 records. It's integrated with OCI metrics. So you'll see metrics related to the DNS queries for the zone. And of course, you can interact with OCI Public DNS, with the web console, APIs, or software development kits. Let's dive into DNS traffic steering because I find it very interesting. As I said, it uses traffic management steering policies to serve intelligent responses to DNS queries. So we define a logic in the policy, and OCI will provide DNS answers according to those logics. And it's fully integrated with OCI's health check service, which will determine the state of the endpoints and adjust the DNS resolution according to that. There are 5 types. Let's look at each of them. So we have the load balancer one. The load balancer, as the name, will load balance the DNS answer over multiple sites. We have the failover, where you have a primary site and a secondary site, and we'll see that a little later on a diagram. We have geolocation steering, where we rely on the location of the requester to provide an answer. And we have, autonomous system steering based on the BGP ASN. We provide an answer to the DNS query. The last one, IP prefix steering, very similar to geolocation and ASN. It's based on the requester's IP. We have a policy, and we provide an answer based on the source IP. Let's dig a little deeper. Well, one more point. These policies can be combined. So you can have, failover and geolocation steering combined. So you have a very, advanced architecture. Let's look a little at the load balancer policy. It's practically simple, right? We have the health check service at the bottom. It will monitor both sides. In this example, I have OCI region Chicago, where we have a web server, and the same web server with the same data is in Frankfurt. The health check service monitors both of these sites. If both are up, the DNS system will load balance the answer. So 50% of clients will be directed to Chicago, 50% of clients will be directed to Frankfurt, if no other policy is in place. Should one of these sites stop responding to health checks, OCI will remove it from the available sites, and all users will be directed to the healthy site. The failover policy. Well, in this policy, you have a primary site. In this example, it's Chicago. If that site stops responding to health checks, you see it gets red in this diagram, then OCI DNS will direct all users to the secondary site or the backup site. This is a very common architectures for DR scenarios. You have your primary site with all of your applications. Should that site go down, OCI will automatically direct all requests to the secondary site. Let's talk about geolocation. It's pretty simple. We have the same application deployed on 2 continents. In this case, we have it in North America, in Chicago, and in Europe, in Frankfurt. If the requester is in North America, they will be directed to the Chicago region. If the requester is in Europe, they will be directed to Frankfurt for the same DNS host name. Now, in this and the next policy types, it's important to note that typically it's not the actual user reaching the OCI DNS servers. It's the user's configured recursive server, right? We don't typically in our browsers or in our operating system choose which DNS server to go to. We have a local DNS server, which is typically our recursive server. So OCI evaluates the request coming from that recursive server, right? It's important to note because it can happen that the recursive server is configured for this example, in a different location than the user, right? So you can, I don't know why, but you could configure your DNS server to be in a different continent. So it's important to note that where the evaluation takes place and what's what's the source of the evaluation. It's the recursive server. Similarly to geolocation, we're talking about ASN steering. Whenever OCI receives the DNS query, it looks at the source IP and it matches it with the database of ASNs, and then it applies the policy. In my example here, one user has 13335 configured, and who can guess what that DNS server is? It's Cloudflare's 1111 DNS server. So if a user has configured Cloudflare as its recursive server, then that user will be directed to Chicago. Any other user in this world, as you see on the right side, they are outside of Cloudflare, they will be directed to Frankfurt. And the discussion on health checks apply. Again, you can have this policy fail over to the other site should the site go down, right? So for example, if Chicago goes down, even the Cloudflare users will be directed to Frankfurt. IP prefix, it's very similar to the previous, but instead of matching it to the BGP ISN, we match it to the actual source IP of the recursive server. And in this case, it's the same example. We have a user that configured 1.1.1 as a recursive server, and another user that configured an Oracle free recursive DNS server. And based on the policy, they will be directed to different sites. Okay, let's talk about DNS zone transfers. I have a, here. So when you define a secondary zone in a system, that that's a DNS server that has the secondary zone will connect to the defined primary system to get a copy of the zone file. After both the primary and the secondary DNS servers are synced, the workflow becomes very similar to what we have on this screen. So we have a zone admin who can change the DNS zone file only on the primary servers. The secondary servers will get the copy, but you cannot change any entry in that system. So after the zone admin configures changes anything in that DNS server that's marked as primary, DNS has implemented through RFCs this system where they can send a DNS notify message, and it's an optional message. Not all systems implemented it, but let's say for the sake of this example, this primary set of servers will send the DNS notify message to the secondary servers. Now, when the secondary servers receive the DNS notify message, they will send an SOA request for the SOA record to the primary. The primary sends back the SOA record. And if the secondary DNS systems see that their SOA record is different, it means that something changed, and they do a zone transfer request. And the zone transfer request can be of two types. It can be an IXFR or an IXFR DNS zone transfer request. The difference is the IXFR, it's a full zone transfer. So basically they ask again for the full zone to be transferred. The IXFR or the incremental one, the secondary servers will send their SOA serial, and the primary servers will check what's the difference between the serial it has and the serial the secondary servers have. And the primary servers do know what changes happened between the two serials. And each time you modify a zone, the serial increases, right? So if let's say at 0.5, at a given point in time, you have a 5 serial, and you go in and you add a record, that serial becomes 6, right? So in this case, the primary zone servers will know what data to send back to the secondary if it's an IX incremental zone request. And the incremental one is again an optional feature in the RFC. Not everybody implemented it, right? The full zone copy, that's mandatory, but the incremental one, not everybody implemented it. In OCI, both the DNS notify and the incremental zone transfers are supported. Now let's talk a little about security. How do you secure this architecture? Well, one of the things that OCI supports is transaction signature keys. You define these keys both in the primary and the secondary servers. And everything you know, when the zone transfer happens, even in the SOA request, everything gets added with that transaction signature key. And if it doesn't match, then the request is denied. And as I said, OCI can be on both sides of this architecture, right? It can be either the primary, and we have a downstream system configured as secondary, or it can be a secondary system for your primary systems, which are in your data centers or in a different service provider. The important thing to note that even if it's a primary or a secondary system, both are authoritative for the zone, right? So in the DNS registrar, like GoDaddy or Dynadot or whatever, you can configure all of these name servers as authoritative, right, for the zone, which provides great flexibility. If something happens to the primary service, your clients will not be impacted because you have a zone copy in the secondary side, right? Now, except transaction signature keys, in OCI, the Oracle Cloud, it's an implicit access list because you have to manually define either the upstream servers or the downstream servers, depending on which side of this diagram you're on. And that acts as an access list, right? So if you manually put that IP there, that's the only IP that's allowed to either request a zone transfer or send the zone data. So it's an access list. This is pretty much it with public DNS. If you have any
Radu,
questions.
I have a question, Radu. Can you tell me if the customer can use DNS traffic steering if OCI it's a secondary DNS zone?
No, unfortunately not. And it's a great question. So in order for traffic steering to work, OCI has to be the primary for that zone because it has to modify the DNS entry to point to a different site, as we've seen earlier. So if you have the zone configured as a secondary, traffic steering cannot work because it cannot modify anything in that zone.
Thank you, Radu.
Sure. This concludes the OCI public DNS side. Let's move to the private DNS. Marius has some interesting things to show us.
Thank you, Radu. Let's move to OCI private DNS solution, which is a robust system designed with security, high availability, and performance in mind. This extensive solution lets you have your own DNS domain names and fully manage the associated zones and records. It provides hostname resolution for application running within the virtual cloud networks, between the VCNs, and your on-premise environment or any other private network. In upcoming slides, we'll explore the core concepts of the OCI private DNS and various scenarios where deploying private DNS can be a game changer for your work. The core concept of the private DNS is formed from the following components. The private DNS zones, which contains DNS data only accessible from your VCN, such a private IP address. They have similar capabilities to an internet DNS zone, but provide security because they will respond only to clients that can reach these zones via a VCN. Private DNS views. A private DNS view, it's a collection of private zones. You can reference private views from a resolver to manage how DNS queries are answered. A zone can only belong to one view, but an arbitrary number of resolvers can use any given views, allowing you to share the private DNS data across the VCNs. Private DNS resolver, it's will respond to queries by checking each customer reference view in order, then the default view, and then each forwarding rule in order, and finally it will use the internet DNS. And private DNS resolver endpoints will are resolver endpoints which come in two flavors. The listening endpoint allows the DNS resolver to answer DNS queries outside the VCN, such as on-prem systems or other resolvers, and the forwarding endpoint, which allows the DNS resolver to query a remote DNS system as defined in the forwarding rules. All the core components are linked together in the following mode. A VCN resolver is the component created automatically during the VCN provisioning. This VCN resolver will be linked automatically or manually to the following components. The default private view is the private view of the VCN created automatically during the VCN provisioning. Once we start populating the VCN with subnets, the subnet default zone is added to the OCI Private DNS by creating and adding it to the default private view. This task will be done for each subnet created in the VCN. Manually, we can create other private views containing one or multiple custom private views, zones. Endpoints are resources that will allow the VCN resolver to interact with other DNS systems and is composed of listeners, which will allow the VCN resolver to access external DNS queries, and forwarders allow the VCN to resolve and send VCN resolver to send DNS queries to the external DNS systems. For redundancy purposes, please remember to use NLB systems within the DNS health check to forward queries to multiple external DNS endpoints. Forwarding rules will allow the VCN resolver to send DNS queries based on the rules you create, offering your company flexibility and security. Those rules can be based on the source subnet, meaning that every DNS query sourced in the subnet or in the source subnet will be forwarded to an external DNS endpoint. The target domain means that queries to a specific domain, for example, google.com, will be forwarded to an external DNS endpoint. And finally, we can choose to forward all the DNS traffic to an external DNS endpoint, selecting the rule based on all traffic. Now, let's see what happens by default when we create essential resources in OCI. First, we deploy a VCN with the name prod_VCN. At the same time, the VCN will be created with the following resources: the VCN domain name, which will have prod_VCN.oraclevcn.com. As you can see, the domain name is formed from the VCN name and from the oraclevcn.com, which is a standard for all VCNs created in OCI. The VCN DNS resolver with the same name of the VCN and the default private view, which will have the same name as the VCN. Once we deploy subnets in the VCN, let's say we deploy subnet 1 and subnet 2, we'll also get two private zones that will be linked automatically to the private view. Once we have the subnet provision, we deploy a compute instance in a subnet 1 with the name PM1. At the same time, an A record will be created for the subnet 1 private zone with the entry point of the allocated IP address of the VM1. We decided also to create another NIC of VM1 in subnet 2. We need to manually create an A record for this NIC in the subnet 2 private zone. But as you can understand, the security of the OCI Private DNS can be still used in this case. Once you deploy the VCN, you get a dedicated VCN resolver, which can add additional private views and private zones. Please note that Oracle will not create DNS entries in your custom private zones, so you must manage them entirely. One final important note in this core concept presentation is that the VCN DNS resolver will answer each query by looking in the configuration with different priorities. First, it will look up the attached private views in the configuration order. Second, it will do a lookup in the default private view. After, it will check the forwarding rules attached to the VCN resolver. And if there is no match in the previous methods, it will look up in the Internet DNS. Now, it's time to look at the common scenarios for building a secure OCI Private DNS architecture. Let's look at a scenario where the client has 3 VCNs deployed in the same region, all paired together through a dynamic routing gateway for network connectivity. The easiest way to have the DNS resolvers know about another VCN domain is to attach the private view of each resolver to the other resolvers as shown in the diagram. The advantages of this scenario, it's easy to and fast to set up. There is no DNS traffic between the VCNs. Can easily grow to more VCNs or more custom private views, and there is no endpoints needed. As disadvantages, we have the VCN must be in the same region, and also the VCN must be in the same tenancy. Different compartments is supported. To implement this scenario, you must go and into each VCN resolver and attach the other private views of the other VCNs. In the previous scenario, we covered the use case of multiple VCNs in the same region and in the same tenancy. What happens if we have multiple tenancies and even VCN in other regions? In this case, we need to leverage the functionality of DNS resolver endpoints and forwarding rules. Let's look at a simple scenario with 2 VCNs in the same region but different tenancies. In this scenario, each VCN will have only its private view attached, one DNS resolver endpoint type forwarding to connect to the other VCN, one DNS resolver endpoint type listening to respond to queries from the other VCN, set of forwarding rules to resolve for the resolver to follow. The advantages of this scenario, the VCNs can be in different tenancies or different regions. Forwarding rules can even be more specific than the whole VCN domain. Disadvantages, it does not scale very good. For each additional VCN introduces more configuration and this DNS traffic. It becomes hard to manage if many custom private views are used. Another interesting scenario is to forward the all DNS traffic to a remote location for additional security. The remote location can have a third-party tool for DNS scrubbing of the bad domains. Let's look at an example where we have 3 VCN in the same region and in the same tenancy. In this case, we'll do the following. We'll designate one of the VCNs as a DNS hub, so keep all the forwarding configuration in a single place. This DNS hub resolver will attach all the private views in the region, including the default ones from the other resolvers. The DNS Hub will have a catch-all rule to forward all non-OCI DNS traffic to on-prem scrubber. The other VCNs designated spokes will have the same catch-all rule to target the hub listener. The on-prem DNS should also have a rule to forward all Oracle VCN.com traffic to the DNS Hub VCN. In this diagram, contains all the information necessary to implement this setup, with the only comment that the forwarding rule will have none as the forwarding condition. Let's look into a more complex scenario where we have the following elements. The primary OCI region with 3 VCNs in the same tenancy, the OCI region with 1 VCN, and connectivity from the primary region to a client data center via fast connector IPsec. Let's take each VCN and discuss the implementation. Similar to the scenario 3, one of the VCN in the primary region is designated as a hub DNS, a role that any VCN can take and is just a virtual assignment. In this, we have the following configuration details. The spoke VCNs, all the VCNs in the region that are not hub, will only be able to resolve their own internal DNS, and it will go to the hub VCN for any other domain, a catch-all rule in the DNS forwarding rules. The hub VCN will act as a central place to manage the DNS resolution and forwarding configuration. It will allow all the domains in the region because it will have all the private views attached, and it will also have forwarding rules for on-prem domains and DR site domains. The DR VCN will target the hub for both on-prem and primary region domains. The hub will answer directly for the OCI domains and forward the query for the on-prem domains to the on-prem DNS server. The on-prem DNS server will target the hub for any Oracle VCN.com queries, and it will answer queries from the hub for the on-prem domains.
Sorry to interrupt. I have a question. What happens if I don't want to use OCI private DNS? Do I have solutions for that, or I really need to use it?
That's a good question, Radu. Let's suppose a customer wants to a solution that is different from the private DNS that OCI offers out of the box. Customer can create a solution using the DSCP options of the VCNs to provide the compute devices with a custom DNS server and make their own DNS servers in OCI. But in this case, the customer must fully manage their zones and DNS server in this case. So based in this short example, OCI allows customer to choose a preferred solution for the DNS that will provide the security and familiarity in administrating the solution. So yes.
Understood. Oh, okay. Thank you.
Thank you, Radu. With this, we finish the common architecture, and I will hand it over to my colleague Aditya, who will give you some OCI DNS demos.
Thank you. Thank you, Radu and Marius, for excellent presentation. I'm going to demonstrate 3 use cases from the presentation, which use OCI's private DNS feature. So let's start with a very simple use case where 2 VCNs are provisioned in the same region and in the same tenancy. This is a scenario 1 from the presentation. 2 VCNs, Phoenix DNS Demo and Phoenix DNS Demo New are configured with the DNS domain names. Each VCN has 2 subnets with a DNS label. There is one resource provisioned in each of the subnet that takes the FQDN from its VCN and subnet. So let's dive right into the demo. So before we make any change, let's go to the terminal and do some DNS tests to see if they work by default. We will be using NSLOOKUP tool for this purpose. First, let's try NSLOOKUP from one of the test computes in the Phoenix DNS demo VCN. First two NSLOOKUP queries are for the hosts in the same VCN, which we can see are successful. Last two queries are for the hosts in the other VCN, which is our new VCN, which are failing. Now, let's replicate the similar tests in the other VCN as well. So let's log into the compute host in the Phoenix DNS demo new VCN. As expected, NSLOOKUP queries to the hosts in the same VCN are working perfectly fine, but the ones to the hosts in the other VCN are failing. Let's see how to fix this. So go to hamburger menu, click on networking, then virtual cloud networks. First, let's go to Phoenix DNS demo VCN. And click on the DNS resolver link. Now, the first step is to attach the private view of the other VCN to this one. So let's click on the Manage Private Views. Then select the Phoenix DNS demo new VCN, which is the other VCN, and save changes. Now let's refresh the page to see the view attached. Let's do the same configuration in the Phoenix DNS demo new VCN. Click on the DNS resolver. And add the Phoenix DNS demo private view to this new one. Now, all the configuration on OCI is complete. Let's go back to the terminal and carry out our DNS tests again. Here, we will try NSLOOKUP again to see to the hosts in the other VCNs which were failing previously. And because we attach the private views of the VCNs to one another, we can see that all the NSLOOKUP tests are now successful. Let's try it from the other VCN as well. Let's try NSLOOKUP on the failed domains once again. The queries are now successful. Going back to the Phoenix DNS demo new VCN. And we can see the same results. It's returning the answers. Now this concludes the demo for a very simple use case of two VCNs in the same region and in the same tenancy. Now for the next demonstration, we will see how to resolve FQDNs in the on-premises network from OCI using Private DNS. This is scenario 3 from the presentation. We have a VCN provisioned in the OCI and connected it to the on-premises network through VPN. On-premises network has domain name hybrid.dns. It has two DNS servers, one for forwarding and one for listening. Two machines with their own FQDN as shown will be used for testing the functionality. Scope of this demo is to show only OCI's side of configuration and not the on-premises side or VPN. Now let's dive into the demo. Before we make any change, let's do some DNS tests to test the behavior before configuration. As we can see, all the DNS lookups from OCI to an on-premises location are failing. To implement the changes required, let's go to hamburger menu, click on Networking, Virtual Cloud Networks, and select the Phoenix DNS VCN. Click on the DNS resolver, and let's create a forwarding endpoint first. Give it a name. Select the endpoint type as forwarding. Select the subnet. Optionally, you can also specify the desired IP address. Now let's create a listening endpoint like the forwarding one. Here, we need to select the endpoint type as listening. If IP address is not specified, OCI assigns random IP available from within the subnet selected. Here we are specifying the IP. The last step is to create a forwarding rule to forward DNS requests for an on-premises domain name to the on-premises listener. For that, let's click on Rules, Manage Rules, select rule condition as domains, select the on-premises domain name, which is hybrid.dns, select the forwarding endpoint, and enter on-premises listener IP as destination. After the status becomes active, let's go back to the terminal and redo the DNS tests again. After we created forwarding endpoint and added a forwarding rule to point all the DNS requests for on-premises domain to on-premises listener, all the NSLOOKUP tests are successful. In a similar manner, you can configure conditional forwarding on your on-premises forwarder to send all the DNS requests for OCI domain name towards the OCI VCN listening endpoint. This concludes the hybrid DNS demo.
Aditya, I have one question. How do you secure these DNS endpoints?
Yeah, a very important point coming from security perspective, Marius. So private endpoints are deployed in the subnet of your choice. So you can either use the security list of the subnet to open required ports, or you can go more granular and attach a network security group to the endpoint and then allow required traffic. Also as Marius explained, right, the endpoints only have private IP associated with it, so they are not accessible from the public internet. Hope that answers your question.
Yep, thank you very much.
Okay, so let's move on to the next use case. So in this last use case, we have two VCNs enabled with DNS name in two different regions, Phoenix and San Jose. They're already connected via remote peering connection. This is a scenario 2 from the presentation. As with previous cases, each VCN has two subnets with a DNS level. There is one resource provisioned in each of the subnet that takes a QDN from its VCN and subnet as shown. A forwarding and listening endpoint has already been created in the Phoenix VCN in our previous demo. Now let's start the demo. Before making any changes, let's do some DNS tests again using NSLOOKUP to see if they work by default. First, let's try NSLOOKUP from the Phoenix VCN. First two NSLOOKUP queries are for the hosts in the same VCN and in the same region, which we can see are successful. Last two queries are for the hosts in the other VCN, which is in the remote region San Jose, which are failing. Now let's switch to the compute host in the San Jose region. Here, we can observe the same behavior. Queries in the same VCN work fine, but to the Phoenix region VCN are failing. This is because resources can only resolve host names in the same VCN by default. Let's fix this. For that, let's go to the OCI console and select the San Jose region. Now let's go to Hamburger menu, Networking, and click on Virtual Cloud Networks. Select the San Jose VCN and click on DNS Resolver. Now, first step is to create endpoints. Let's create a forwarding endpoint first. Give it a name. Choose the subnet and specify the IP address. Now, in the similar manner, let's create a listening endpoint as well. Follow the same steps. We'll give it a name, select subnet, and select the endpoint as listening endpoint. Let's give it a minute until it creates the endpoints. At this point, we have completed the OCI configuration. Oh, before the last step, we need to add a forwarding rule. So based on the domain that we have in the Phoenix region, which is Phoenix DNS demo, we'll select the endpoint as forwarding endpoint, and the destination IP address should be the listener IP in the Phoenix VCN. So now all the requests towards the Phoenix VCN are getting forwarded to Phoenix listening endpoint. Now let's change the region to Phoenix. Go to the Phoenix VCN, click on the DNS resolver. Now we already have created the listening and forwarding endpoints in the previous demo. Let's skip to the rules directly. We'll add a similar rule as we added in the San Jose region. Select the domains. Then here we will enter San Jose VCN DNS name. Source endpoint should be forwarding, and destination should be listening IP in the San Jose region. Once the rules are added, this should be all the configuration that we need from OCS side. Now let's go back to the terminal and try the NSLOOKUP tests again. Here, we can see that the NSLOOKUP queries to the other VCNs resources work as expected. This is because the endpoints configuration and the forwarding rules that we have created. This concludes all of the demos that we wanted to show. Now back to Radu for the presentation.
Thank you very much, Aditya. Great presentation. Resources. We have many blogs. These are just examples of some of them. Many of the things discussed in today's presentation are in these blogs. We also have a live lab. A live lab will guide you step by step on implementing DNS traffic steering. So if you have an OCI account, even a free account, you can use traffic steering and test DNS resolution. And in general, we have a lot of training materials. You'll find them if you click on these links, and certifications. Let me look a little at the questions so we can discuss them. I'll start with the open ones. So how is this service different from Akamai Fast DNS? Well, they are very similar, meaning Akamai being a CDN, they have, of course, a very extensive network. So I would say they are pretty similar. And I believe that this, when you say this service, you mean OCI Public DNS. I think we have, the traffic steering, which might be a plus for oracles, but in general, the public services are pretty similar. OCI DNS is a Oracle managed service. What is the SLA of this service? Does Oracle automatically handle high availability NDR type requirements? Well, as explained, whenever you use the OCI Public DNS service, you get a copy of the service in each OCI region. So you have extremely high availability. There is no necessarily a DR concept, right? It's you have that zone copied in all of the OCI regions, so it's pretty improbable that all of OCI's regions will have issues answering to DNS questions. The SLA, we can find it in the public documentation, but it's a generic network SLA, right? 99 dot something. Albert is asking, I'm looking to replace on-prem DNS servers using OCI DNS service instead. Is that possible? I think Arvin misunderstood your question. It is completely possible to use Oracle's DNS services for both public and private systems, right? So if you have an on-prem service, if it's bind, export the zone, import it in OCI, and everything will work, both for public and private. Albert, you're asking back, can we use OCI DNS private zone to host an on-premise DNS that uses simple bind service? Yes, you can configure your own zone inside OCI. So customer.com, right? Whatever zone you want, you can configure it in OCI and it will work. You will have to point all of your resources for OCI to the OCI's DNS IP, right? Internal private IP in one of the VCNs. So it gets a little complicated on the network side. If your systems are on your data center and you want to use OCI's private DNS, they will have to come to OCI over a private link, IPsec, Fast Connect, anything like that to get resolution. But technically, yes, it's possible to use OCI DNS for private zones, your own custom private zones. Ramon is asking, can I route DNS queries through my Fast Connect or point-to-point tunnel back to Oracle, but for Oracle global services like SAS, IDCS, and object storage? So Marius presented that you can deploy listeners in OCI on the private side. Those listeners will answer to any request, including SAS, PAS, IDCS, or generic public zones, right? So if you want to query that listener for oracle.com, which is a very public zone, you can do that. Meaning you can direct any DNS traffic that you want to the OCI listener and it will answer. If it's a public zone, it has ways to answer for public zones. So yes, Ramon, you can do that. Does OCI DNS private zone support PTR records for reverse lookup on-premise DNS? Yes. For OCI's automatically deployed zones, you get automatic PTR records. You can also create your own pointer reverse records. Okay, thank you everybody for joining this session.
Thank you so much, Radu, Marius, and Aditya for this great session. I know that people are still asking questions. I put an email address here. If you still have questions after the session, please feel free to put your questions in there at personaltrainers_us@oracle.com. And I'll be more than happy to direct your questions to the right presenters. I hope everyone learned something new today. Our next session will be on Monday, July 15th, and our topic will be networking best practices, where network experts will cover their best practices, recommendations, and lessons learned for customers as they plan, deploy, and manage their OCI network infrastructure. Again, I recommend that you bookmark the Devon and Beyond page and check frequently for new sessions that we keep adding on trending topics. With that, thanks again for joining us. See you all next time. Have a great day, everyone.